Okay, guys, so welcome back to the exercise. We're gonna be doing this exercise of our exercises. I'm just gonna guide you through. So yeah, let's go do this real quick. The important part here is that it gives us the following. It will give us the following. Oops. It tells us the following data. We have a four values digital signal. We have an Einspannungsbereich of 0, 0 to up to 5 volts. And we have 1/3 of the interval. It should be for the Bereich. So what we do is the following. We have this and we write our data. So once we have our data, I can do the following. I can say, okay, I have 4 signals, right? And I want 4 signals, meaning I have to do my little box here. We create a little box. And I want to see how many, so to speak, divisions I need to do. So in this case, I want 4, meaning I need to do 3 divisions, right? So 1, 2, and then maybe 3 over here, right? So we have our 4 signals, 1, 2, 3, and 4, meaning we have 3 divisions, right? So we're gonna do 4 plus 1/3 plus 1/3 plus 1/3. That will give me, in a sense, 5, right? So that's pretty much how it goes. It tells us, hey, we have 5 volts. No, not 5 volts. Yeah, no, we don't have 5 volts. We just have 5. That's pretty much it. It's not volts. So now we're gonna take our limit. So it's 5 volts in this case. We're gonna divide 5 volts divided by 5 is gonna give me 1. So meaning that this little here is what each digital interval is equating to in volts. So it's 1 volt per signal, meaning that something over here will be 1 volt, this one over here will be 1 volt and stuff. But now we want to know how many volts we would need for our undefinierte Bereiche. To do that, it's quite easy. You have to do the following. You have to do how many signals we have? We have 4, right? So if we have 4 signals, so we're gonna do 4 times the value of this of each signal. So in this case is 1. So we get 4 volts. So now we're gonna do 5 volts minus 4 volts, and we get our result, which is 1 volt. Meaning we want to now find how many like we have to divide this 1 volt into 3. So 1 volt for 3, meaning we do 1/3, right? So now if we do our intervalle, so to speak, it'll look something like this. Let me just do it real quick, right? The first interval, so this is one that's important. The important data here is this one and this one over here. So what I'm gonna do, it starts from 0 and then goes up until 1 volt. Then we have undefinierte Bereich, so we're gonna do 1 plus 1/3. That's gonna be 4/3 if I'm correct. So it's gonna be 4/3. And then 4/3 plus 1 is gonna be 7/3. Again, 7/3 plus 1/3 is gonna be 8/3. Then plus 1 will be 11/3. 11/3 plus 1/3 is gonna be 12/3, which is gonna be in this case 4. And then 1 is gonna be 5. So in this case, we can just write the following. 4/3 is 1.5. No, how much is 4/3 actually? 4/3 is 1.333. And 7/3 is, if I'm not mistaken, 2.3. 8/3 it'll be 2.6. And 11/3 is 3.6. So we have now this, and then we can actually make our divisions. So let's start with that. So in the first one, we go from 0 to 1. So we go from 0, right, up until 1. So 1 is gonna be a division here. Let me just erase this. Do it again. There we go. I'm gonna go back. I'm gonna check that out. So it's 0 to 1, and then it goes up until 4/3, right? So 4/3 is 1.3. So in this case, we have 1, 2, 3, 4. So in this case, oops, I deleted my line. Great. If I'm not mistaken, oh gosh. I have so many allergies. I'm so sorry, guys, about the boogies and stuff. It's just impossible to deal with it. So it's going to be 1.2, 1.4, 1.6, and 1.8, and then 2, right? So if we want to find 3, 1.3, it will be like a bit in the middle, I suppose, a bit more than the middle. So it would be something like that. It doesn't have to be perfect. Like if you get this in the test, you don't have to get it perfect. You just have to get like an approximation of where it is. So 1.3, I would say is there, right? Now we can do our little square here. Obviously, this is way quicker with the iPad. If you have just paper, it's okay. It takes a bit more time because I can just group this and I can just duplicate it, right? So now I can check out that we begin from it goes 1.3 up until 2.3. So you gotta see where 2.3 is. This is 2.2 over here, and then 2.3 is a bit more in the middle, around there. Yeah, there we go. And then the end, 2.3, and then it goes to 2.6, and then, well, yeah, we just go to 2.6 in this case. So in this case, hold on. I'm getting confused over here, you guys. 2.3. So it begins in 2.3. The division begins in 2.3, yeah? And 2.6, we begin in 2.6, so to speak. That makes no sense though. So this will be 2.2, 2.4, 2.6. Oh no, it does begin 2.6, and it ends in 3.6, meaning we just have to have, we just do here 2.8, 3.2, 3.4, 3.6, 0.8, and it ends in 3.6 if I'm correct. Meaning we have to write something like so, right? And that's pretty much it. That's pretty much how it goes. These are our divisions. Now we're going to begin with Wertdiskret. This is quite easy. We just begin at the starting point. So in this case, we start in the first block, right? And it stops being the first block around in this area. So we're going to do a line here. This is the Wertdiskret, and it will go up till, I don't know, over here in the middle. I don't care. It doesn't really matter where we put it. Now we're going to check it out where it goes back down. So in this case, it goes back down around here. Right? And just fix this. And then we can say, hey, it'll stay up in here up until it leaves around here again. Oops. Okay, perfect. I messed it up, dude. Hold on. There we go. So it will go up until here, right? And it'll stay there up until we get to around here, actually. So not that much time. And then it'll stay here, right? It'll stay here for quite a bit of time. Well, actually not that much time. It will stay up until here, actually. So let's put it over here. Oops. And we can put the line over here. Doesn't really matter, does it? So we just put this like that, like so. Perfect. Now, let's keep going. This will go here. Then this guy will go here. Right? Then this guy will go over here. I'm just speeding through this because I'm just lazy at the moment. Yeah. Oh gosh, no. This will go up until, like so. And like so. And then this guy goes up until here. Right? So now we can just join everything up. So we can go just and put it here. And it goes like that. You can close this up. This guy will go down up until around here. And then we'll connect here. Then this guy will go down up until here. Oopsie daisy, that looks disgusting. And that goes here, that goes there. And this guy will go up until here. And this will stay like so. And then this will stay like so. So now we're done with the Wertdiskretisierung. Now we're going to do the Zeitdiskretisierung. Over here I made a little mistake. This should be like so. Right. Okay, cool. Now we're going to do the Zeitdiskretisierung. Now this one is block by block, remember? I'm just going to put it under this. This, we don't want to like overlap it because we don't want to do this and get confused. So we're going to put it a bit under. So this one begins, as you can see, if we start, it begins in the first quadrant. So it stays one block in the quadrant. Then we go up, and you can see it goes to the second quadrant. So it has to go up here. So we have to do the following, like so. Right? Now we check the next value. It's over here, so it stays in the second quadrant again. Now we check once again. It's over here, so it goes down once more. If I'm correct, I should be able to do something like this. Duplicate this and put it like that. This guy will stay up until, well, this guy stays here. And then we check again, still stays here. It checks again, it's still in the, well, over here we're checking this one. It's still in the undefined area, meaning it still stays in the same quadrant. Not quadrant, but like same area. Then over here, as you can see, it goes way, way up until here. So it goes over here, I suppose. Let me think. Yeah, it goes there because it goes here. So it'll stay like so for one block. Let me check the next little line. It goes all the way up until here. So it means, yeah, basically it goes up here for this quadrant for a square. Then we check the next value is up until all the way over here. So it goes also to the next quadrant, so to speak, for one square. Then we check the second square stays in the same because it's in the same point, as you can see. Over here, we're gonna check where it is. It's still in the same one, so we stay here. Now here, we're gonna check where our quadrant is over here, so it stays there still, so to speak, because it's the same in undefined area. Over here, finally goes down. As it goes around, ooh, that's a good one actually. It goes down up until here actually. So we have to go all the way down, if I'm correct. Like so. So let's do that like so. Okay, perfect. For one square. The next square is down here. As you can see, it goes down here, so it has to go down again. Oops. We're almost done. It stays in the same quadrant, so we can keep on going here. Here, well, yeah, it's the same quadrant, so it stays here again. Over here, it's in another quadrant, so we can just go there. Yeah, over here I made a mistake with this one. It should be over here. If I'm correct, yeah, there we go. Not that big of a deal, but whatever. Over here, it goes up. Why? Because we can see that this guy, the value is over here, so it goes up again. And this stays there. And that's pretty much it. So that's our, so to speak, table. So yeah, that's our table. That's pretty much how you do it. It's not that difficult. So now you guys have to just try to do the other ones. The solutions are already on the drive. This, guys, you can also like do them yourself. I don't think it's that big of a deal. So yeah, thanks for watching.